Now let us solve these questions. Normally such a figure will be given and they will ask to find the magnetic field at the center, somewhere at the center. And in all such questions, the two equations which comes into action or which you have to use is the magnetic field nearby an infinitely long conductor, which is B equals mu 0 I by 2 pi r, and the magnetic field at the center of a current carrying circular coil, which is B is equal to mu 0 I by 2a. If you know these two equations, you can solve all of these figures. So let me check the first figure. Here is a conductor which has a ring over it. But the two ends are though not meeting. This end is not meeting the other wire. So a current I is flowing through this, and the radius of this circle is A and the center is O. They are asking you to find the magnetic field at O. See, to find the magnetic field at O, you have to use both equations, because you have a circular loop through which a current is flowing, and you have a long conductor from where you have a point P which is A distant away. You have a circular loop whose radius is A, and you have a infinitely long wire from A distant away. You have a point P which is A distant away, where you have to find the magnetic field strength. So first case, you have to write B due to circular loop mu 0 I by 2a. That also creates a magnetic field at the center. Similarly, the long wire also creates a, let it be B2, which is equal to mu 0 I by 2 pi. R is the distance, so here it is also A. So both magnetic field are present at the center. So net magnetic field is equal to B1 plus B2, which is equal to mu 0 I by 2a plus mu 0 I by 2 pi a. So you can take mu 0 I by 2a outside. So you have 1 plus 1 by pi as the answer. So logically what you have to do is you have to apply both the equations, one for the circular loop and one for the long, infinitely long wire. So this is for this one. So B is mu 0 times I by 2a 1 plus 1 by pi. So take this second figure. You have a figure like this. So this is A, this is the center O, and this is also A radius, and this is also A radius, and through which a current I is flowing. Here you can see this curve is the part of a circle. So you have only hemisphere part out there. So you have to use the same equation, D is equal to mu 0 I by 2a, which is for the sphere, circle. But it is, you only have the half of it, so you have to net magnetic field at the center will become to half of it. So you have mu 0 I by 4a as the answer. So this is how you have to solve this one. So it is B is equal to mu 0 I by 4a. Now look at this figure. Here also one current is flowing. This is the point, this is center O, and this is the radius A, and you have to find the magnetic field at O. So here you can consider two things. See, this is again the hemispherical part. So its contribution is half of, so let it be B1, it is equal to mu 0 I by 2a by 2 half of the circle. So it becomes B1 is equal to mu 0 I by 4a. Now you may have a doubt that, see, these ends can be considered to be part of a infinitely long wire. Don't they contribute the magnetic field at B? See, when you write the biot saverts equation, dB is equal to mu 0 by 4 pi I dl sine theta by r square. Now this sine theta is the angle, this is dl, a conductor on which you take a small current element dl through which a current I is flowing. You consider a point P which is r distant away, and this is the angle theta. So this angle is what you represent by the sine theta, sine of that angle. Now in this particular case you can see the conductor and the point and all the point lines along the conductor. So what is the angle which it will make? So this P point is somewhere along the conductor. So what the angle which it make? The angle will be 0. So this length of the wire does not contribute for B at O. So its contribution is 0. So net magnetic field at the center is equal to mu 0 I by 4A. Now check this figure. You have a conductor and which is making an angle of alpha, and this is the point O, and through which a current I is flowing. The radius of the circle is A. What is the magnetic field at O because of this sector? So in this case you have to use B is equal to mu 0 I by 2A. If you use the biot saverts law directly, so you can write dB is equal to mu 0 by 4 pi I dl sine theta by r square. Here r is A, so I can write it as A square. So sine theta is the angle between the current element and the point. So this is theta. Here the current element is this and the point is center, so it is always perpendicular. So sine theta will become 90, sine 90, so it will become 1. So you have mu 0 by 4 pi I times dl times sine 90 becomes 1 by A square. Now how much is this dl? Total length from this end to this end. How to find that? So that is, if you take arc by radius is the angle subtended. So this arc length will be equal to angle times radius. So here angle they have given it as alpha. So in place of dl you can substitute alpha times the radius is A. So you can write it like dB is equal to mu 0 by 4 pi I. In place of dl you can substitute alpha into A divided by A squares. So you have dB equals mu 0 by 4 pi I times alpha by A as the answer. So always remember these figures, it may be sometimes doubtful how to solve, but in all these cases only two equations comes into action, and whenever you see a half circle, always keep in mind that it is half of the magnetic field created by a circular loop. Thank you.